Hey everyone, welcome back to InfoGamer. In this video, we want to get back into creating our Super Mario Run game. Now in the last video, we were busy showing you guys how to set up your project and create your scene. And so we created our file system and we made sure that our camera was set up properly and we were able to save our scene so that we can remember to save it frequently. In this video, we want to start coding the player and get the basic movements down. So let's get started. So here we have our project open in Unity, and the first thing that we want to do is start creating our environment. And so there's two things that we're going to add to our scene. The first one is going to be a cube, which is going to be the ground for our player to run on. And so to do that, let's go to our hierarchy window, select create, then go to 3D objects and then cube. Let's go ahead and rename this to ground. And this is just going to be a placeholder or a testing object used for early development. And so when we're blocking everything in and making sure the code works, we don't necessarily need to be using crazy models or 3D models. Instead, what we want to do is just use rudimentary shapes so that we can make sure that the gameplay is working, and then later on we can go back and add the awesome artwork and 3D models. And so for this ground object, let's go ahead and zero its transform in the scene. So 0, 0, 0, and then let's drag it down in the Y direction so that it's close to the bottom of our scene. Now what we want to do is scale it out in the X direction so that it's really long. And I'm going to go ahead and open it in our scene, or open our scene view, and then click on the X component of our scale and just drag it out until it at least reaches beyond the edges of our screen. But we could even go further. Let's go ahead and make it maybe 50. And then we can also drag it to the right so that the left side of the ground is just outside our camera view. This makes it so that we're going to have one direction that our character is usually running, and so that we have more ground in that direction, we want to drag it to the right. Now what we can do is add our player to the scene. And so players, when you're blocking in your player or using a placeholder for your player, you most commonly want to use a capsule. And so if you go to create in your hierarchy window and then 3D object and then find capsule, this is a good object to use for basic humanoid characters. And so let's scroll in on our character, and to do that you can also click F on your keyboard and that will focus in on your character. Let's go ahead and zero his transform in the X, the Y, and the Z. And then we can drag him to the left so that he's closer to the left side of our screen. And let's drag him down so that he's closer to the ground. Now what we want to do is we can go ahead and remove the capsule collider, because what we're going to add to our player is a character controller. And so to add this, we want to go to Add Component in the inspector, go to Physics, and then Character Controller. Once you've added your character controller, we can once again focus in on our character or our capsule, and you can see that there's this very faint green line that goes around the circumference of our capsule. And this signifies the capsule collider. And so the reason why we removed the capsule collider from the initial capsule object was because the character controller adds a capsule collider to your character. And so the capsule collider is kind of contained within the character controller component. So you don't necessarily need to worry about having a separate capsule collider. All the options inside the character controller we're going to leave alone for now, but what we want to start doing now is coding our main character. And so let's go to our scripts folder and let's right click, go to create, and then C# script. Let's go ahead and rename this to something like player controller. And I have caps lock on, so player controller. Let's go ahead and open it in Visual Studios. So once you have it open in Visual Studios, the first thing that we want to do is create gravity for our player. Now if this was just any object in our scene that we weren't controlling as a player, we would probably use a rigid body, and rigid bodies come with a gravity option where Unity kind of takes care of it for you. Whereas when you're using a character controller, you have to program gravity yourself. But it's quite easy to do, so let's go ahead and create a new function for our gravity. So it's going to be void, and then let's just call it gravity, or even better, my gravity. And then we need parentheses and curly braces. For this gravity function, we're going to need to create a couple variables to control. And so at the top of our class, let's go ahead and create a public, and then the first one's going to be a character controller, and let's call this my controller. And then the next two variables, one is going to be a public float, and this is going to be our gravity velocity or force or whatever you want to call it. So gravity speed, let's call it, or let's call it gravity force. It's a little more accurate. Next, we want to create a current placeholder or variable to hold our current player's y velocity. And so this is going to be a public float, and let's call this y speed. Okay. Inside our gravity function, we want to first get the current velocity of our player. And so to do this, let's type y speed equals controller, or my controller, and then dot velocity dot y. So this looks at the velocity or the current speed of our character, and then only gets the y component and saves that inside our y speed variable. Now what we need to do is modify the y speed variable, and so we're going to type y speed equals, and we can actually type minus equals, that'll save us some code, minus equals, and then our gravity speed, or gravity force, times time dot delta time, semicolon. So this is taking our y speed and it's subtracting the gravity force from our y speed, so it's making it more negative. So if our speed is currently negative, it's going to increase how fast our object is falling. And so this is the code that we need for our gravity, but we haven't yet applied our gravity, and that's what we want to do next, is create an applyment function. And so let's type void, and this function let's call speed apply. Speed apply. And the first line of code inside this function, we're going to be moving our character controller, our main character, in the y direction. So this line of code will be our my controller variable component or variable, and then we're going to do dot move, and inside this function we need to pass a vector3 parameter. And so we're going to create a new vector3. So new vector3, and then inside this initialization function, we want to pass in a 0 for the x, and then our y speed for the y, and a 0 for the z. And then let's go ahead and hit an exclamation point, and then we need to apply these functions in our update. So I'm going to call my gravity, and then parentheses semicolon, and speed apply, and then parentheses semicolon. Let's go ahead and save this, and then go back to Unity, and we're going to test to make sure gravity is working. So the first thing that we need to do is apply this script to our main character. So I'm going to select our capsule, and let's also go ahead and rename our capsule to player, and then let's drag our player controller script onto the inspector, and we need to set a couple values. And so let's actually go back to our script, and I'm going to make our character controller private, and then in our start function let's type my controller equals and then get component carets and then character controller, and then outside the carets parentheses and a semicolon. This just makes it so that we don't have to worry about making sure that our character controller variable is assigned, because our script's going to take care of it. So let's go ahead and save this, go back to Unity, and you can see that my controller disappeared, and we don't need to worry about that because our script's going to take care of it for us. Now what we need to do is assign a gravity force, and so let's go with real world gravity. Let's type 9.8, and then our y speed we can leave alone because this is just going to be a placeholder or a variable that holds our current speed, so that's going to handle itself as well. Let's go ahead and hit play, and there we go. So you can see that our character fell until he hit the ground. Let's show you one more time, and in this case I'm going to drag our player up towards the top of the screen. So when I hit play, you'll see that our player, or our capsule, falls until he lands on the ground. And it was a little fast, and so if you want to slow that down, you can also go to your speed apply function, and outside the parameter, the parentheses for your new vector3, we can type times time dot delta time. Let's go ahead and save that and go back to Unity and test it one more time. Yeah, that's a lot better speed. So let's go ahead and hit play, and now let's go back to our script. The next thing that we want to do is add a jump function. And so let's, underneath our speed apply, or let's put it above our speed apply. Let's have our speed apply be like near the bottom of our script. So let's type void, and let's just call this jump, parentheses, curly braces. So for this function, there's a couple variables that we're going to need to create again. The first one at the top of our script is going to be a public float, and this is going to be our jump force. The next one is going to be a public float, and this is going to be our hang time. And the next one is going to be a public float, and that's going to be our, let's call this our gravity modifier. So in most Mario games, especially the 2D side-scroller ones, I'm not talking about Mario 64 back in the day or the new Mario, I don't know how that one's going to work, but all the 2D side-scroller Marios, they have a variable jump where depending on how long you're holding the jump button, your character will jump to different heights. So if you just tap the jump button, your character will do like a tiny jump, whereas if you tap and hold the jump button, your character will jump to his max height or jump height, and then he'll start falling. And so we want to recreate that same ability in our game, and to do that we need the hang time variable and the gravity modifier, and so that as the players hit the button, it will continue to push them up into the air until they let go, or until our hang timer runs out. So let's type an if statement, and inside the if statement let's type input and then dot get button down, or actually we just want get button, not get button down. And so if we did get button down, we would just check the initial frame where the player has pressed the screen or even clicked the mouse. But if you use get button, then it's going to check to see if the player is constantly pressing the button down. And so let's, inside this get button function, type fire1, and we can spell it with a capital F, fire1. And then let's open this if statement. Inside this if statement, we want to first check to see if our player is grounded. And so to do this, we're going to type if, and then my controller, and then dot is grounded. So the is grounded is a variable that is part of the character controller class. And it's a Boolean value, so it's either going to be true or false. If it's true, that means our player is touching something on the bottom side of the capsule collider. If it's false, it means he's somewhere up in the air. And so we want to first initially check to see if he's grounded, and then there's a few things that we want to do in case he is grounded. The first thing is to reset our hang time. And so we actually only created a hang time, but we also need to create a public float hang timer. So hang time is going to be like a constant value that we set beforehand depending on how long we want our players to stay up in the air. And then our hang timer is going to be like our Y speed. It's going to keep track of what the current value of our hang time is. And so inside this if statement, we want to type hang timer equals hang time. So hang timer equals hang time. So our hang timer, which is our current value, is going to be reset to the max value, which is our hang time. The next thing that we want to do is give our player an initial jump force. And to do this, we want to type y speed and set it equal to, and then jump force, not jump force. There it is. So our y speed is the current y velocity, whether our character is going up, or in other words jumping, or whether he's falling, in other words he's got gravity applied to him. And so we're going to, in one instance of a frame, switch our player from falling in a negative y speed to going up in a positive y speed. So this is going to be our initial jump force. Outside this if statement, we want to check to see if the other condition is true. So we're going to type else. In other words, our character is already up in the air. Then we want to do a few things. The first thing that we want to do if our player is already up in the air is check to see if his hang timer is less than 0. So hang timer with an R is less than, actually let's check to see if it's greater than 0. If it's less than 0, we actually don't want to do anything because we want our player to fall with gravity. So the first thing that we want to do inside this if statement is subtract time from our hang timer. So we're going to type hang timer minus equals time dot delta time. And then what we want to do is we want to continue to apply a positive value to our y speed depending on what our current hang time is. So I'm going to type y speed equals, and then we want gravity modifier, which is that variable that we created, and then we want to times it by our hang timer with an R, and times it by time dot delta time. So the last thing that we need to do for getting our jump functionality is to call our jump function in the update. And let's do it before our speed apply function. So let's call jump and then parentheses and semicolon. Let's go ahead and save this and go back to Unity and test out our jump functionality. Once you're back in Unity, the first thing that we need to do is set the new variable values that we created. And so y speed's fine, we already had that. Jump force, let's set it to something like 5. And hang timer, we don't need to set, but hang time we want to set to something like 0.5, maybe even 0.25. And then gravity modifier, let's set that to half of our normal gravity, so 4.9 would be half. Okay, let's go ahead and test this out. So if we hit the play button, our character falls to the ground. Once he hits the ground, we hit jump, and we have a little bit of a jump. It's kind of small, and we need to fix it. So I figured out the reason why our character was only jumping so high. The reason why is because we're setting our y speed to our gravity modifier, which isn't very big. And so what we need to do is we need to add our gravity modifier to our y speed. We don't want to set it equal to. And so if we do right here in our else if, our else and then if hang time is greater than 0, the second line, so this one, when we do y speed equals gravity modifier times hang time times delta time, what we actually want to do is y speed plus equals gravity modifier times hang time times time dot delta time. So let's go ahead and save that and go back to Unity and test it out. Let's hit play. So our player's falling, and then when we click this jump button, or we click our mouse, or we even were to tap our screen, you can see our player is now jumping. And the reason why he's actually not got a variable jump is because we need to change our gravity modifier to be actually something bigger. And so our initial jump force only brings our character to the minimum jump height, which is what we're reaching, but because our gravity modifier is too small, it's not doing anything but keeping our player a little bit longer in that minimum position. If we want our player to jump even higher, what we need to do is change this to a bigger number than our gravity. So something like 20. Now when we go ahead and hit play, you can see that if I tap, he's still got that minimum jump, but if we tap and hold, he jumps a little bit higher. And if we wanted to go a little higher than what we were currently doing, we could even bump this up further. So let's try 30. Let's go ahead and hit play. And when I click, he jumps much higher than if I just click and tap. It's like a full body higher. And we could even bump it up further, maybe 50. Let's try this. I want to get him back up to the top of the screen. Yeah, there we go. That's like 3 body lengths taller. So you have that variable jump, all dependent on how long you're holding the button down for. The last thing that we want to do is apply a X direction or a forward direction movement speed. So to do this, let's go back to our script in Visual Studios, and what we want to do is create a new function. Let's put it before our speed apply, and this is going to be a void, and let's just call this forward movement. Then we need curly brace. So for this forward movement function, we're going to need to create a couple variables to use in this function. So let's scroll up to the top, and the first one's going to be a public float, and this is going to be our forward speed variable. And so this forward speed variable is going to be like our y speed variable, where it's going to hold the current value of our player's forward speed, or our z speed, you could say. And so the next variable is going to be a variable that we're going to add to our forward speed to increase his movement. Or actually, we're going to lerp our forward speed to this speed. So this is going to be public float, and let's call this walk speed. And since this game's going to actually be like a Mario Run game, we actually want to call this run speed just to be consistent, because our player virtually won't ever be walking. He'll be running. So let's type run speed. And the last variable that we're going to need for this function is going to be a public float, and this is going to be our lerp time. So the amount of time it takes to lerp from the current speed to our run speed. And now what we need to do is scroll down to our forward speed or forward movement function. And the first thing that we want to do inside this function is to check to see if our main character is grounded. So I'm going to type myController dot is grounded, and if it is true, then we want to lerp to that speed. And so let's type our forward speed variable and set it equal to, and then math f dot lerp. And we want to take our current speed, so our forward speed, and lerp it to our run speed, and we want to do this within our lerp time. And let's add some conditions so that our lerping isn't messy, because a lot of times a lerp function will get you really close to the value that you want, but it'll take a really long time to actually get there. It'll start increasing your decimal value. And so let's type if, and then we want to check to see if our forward speed is within a certain distance from, or a certain value from, our run speed. And so let's say if it's less than or equal to our run speed minus, and then we need a buffer, so let's do like 0.1, then we want to lerp. Or if it's, we could even type if it's greater than. So let's say or, so 2 bars, 2 vertical bars, and then forward speed is greater than or equal to run speed, and we need plus 0.1, and we need an f, 0.1 f, and we need a f after this 0.1. Okay, awesome. So if we're not within that buffer, we're going to lerp towards that run speed. But if we are within that buffer, we want to set it to the run speed. So else, then we say forward speed equals, and then we set it equal to run speed. Now what we need to do is call this function in our update function. So I'm going to type forward movement parentheses semicolon. And the last thing that we need to do is apply our current forward speed in our speed apply function. And to apply this value, we want to type myController.move, and then inside this move function, we want to call transform.forward. And transform.forward is a nice way to get a vector 3 that is always the value of the angle that you're moving at. And so if I was moving in the x direction, then the x would be a 1 and the z would be a 0. But if I was moving in the z direction, then the x would be 0 and the 1 would be, or the z would be a 1. And if I was moving somewhere in between x and z, say like at 45 degrees, then the x would be 0.5 and the z would be 0.5. And so you would be moving in a diagonal line. And so forward, and that's all dependent on which direction your character's z component is facing. And so if your z component is facing in the x direction, then the x is going to be 1. If it's facing in the 45 degree angle, then it's going to be 0.5 and 0.5. Then we need to times this transform.forward value, or this vector 3, by the speed that we're moving. And so that was forward speed that we want to times it by. And then we want to times it by time.delta time. Then we leave it with a semicolon. Let's go ahead and now save this, go back to Unity, and we need to then set the values of the new variables that we've created. And so forward speed we can leave alone because that's like our y speed. And then our run speed, let's go ahead and set it to something like 5. And our lerp time, let's go ahead and set that to like 1. So once we've set all these values, there's one more thing that we need to do for our player, and that is rotate him so that he's facing the direction that we want to go. If we focus in on our player in the scene view, you can see that there's these 3 different colored arrows to signify the directions of our position. And so the red represents the X direction, the green or yellow represents the Y direction, and the blue represents the Z direction. And the blue is the important one that we want to focus in on, because the blue represents the forward direction of our transform. So since we're using the transform dot forward times our movement speed, this is the direction that we want our character to travel, or the direction that he will be traveling, because that's how we coded him. And so we want this blue arrow to travel towards the end of our ground, going from left to right. And so what we want to do is make sure that our transform is set to local. And so up here, underneath our different drop-down menus, you can see this pivot button and this local button. If it doesn't say local right here, it's going to say global. And what you want to do is make sure this is set to local. Otherwise, this won't change. Or you won't be able to see it change. And so once you have it set to local, we want to rotate our character 90 degrees in the Y component of its rotation. Now you can see that the blue arrow is facing the direction that we want him to go. We want him to travel down from left to right, down the ground, or down the scene. And so now that we have him facing in the right direction, we can go ahead and hit play. And what's going to happen is our character is going to fall until he hits the ground. Once he hits the ground, he's going to start running or traveling down from left to right, down the ground, or in our scene. So let's go ahead and hit play. So he's falling, he hits the ground, and he starts running, and he's always running at a constant speed. And as well, if I were to hit play, and then he falls and starts running, if I click the screen, you can see that he's jumping. And so he's going to keep traveling down the ground, down the line or the cube that we created until he falls off. And so what we're going to need to do in future videos is we're going to need to have the ground pre-developed or developed dynamically. And so if you were building a game like Mario Run, you would have levels that are already designed, and you would create the levels beforehand and add them as different scenes in your game. Whereas what we're actually going to do is we're going to create a dynamic changing environment. And so our game's actually going to end up being a little bit more like the game Temple Run, where it's an infinite scroller. So we're going to do like a Mario Run, infinite scroller, Temple Run type game, where the ground is going to be dynamically, or through code, we're going to instantiate different segments of ground that are going to change the difficulty of our game and such. But that's everything that we're going to cover in this video. We now have a player that can jump whenever the user clicks the screen or taps the mouse button. And we also have a consistent running down the ground, or from left to right on our screen. So thanks for watching this video. We hope you enjoyed it. Make sure that you leave a like and subscribe. If you have any questions or concerns, make sure that you leave them in the comments below, and we'll see you next time.